Hello, bonjour, and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and in today's episode, I'm excited to welcome Olivier Narbey as my guest. Olivier's curse is to be one of my colleagues at GF Piping Systems, which prevented me to open him the microphone for a while, as I didn't want you to think that this full podcast series was hidden advertising. And indeed, it's a pity I've waited that long because I know few water professionals with as much experience and incredible stories as Olivier. He'll explain in a minute how having worked for the 3 French majors and in fascinating countries like Algeria, Azerbaijan, Armenia or Mozambique gave him a unique view on our industry, and you'll see that we dedicate our deep dive today to one of the hottest topics there is in the water sector, non-revenue water, the size of the challenge, and how to address it. But you know what? I'm not going to spoil too much of it. I'll just reveal that I said something that pissed Olivier, which led him to deliver one of the most passionate and engaging explanations of a topic we ever had on that microphone. So last stop before we take off, please take a minute to share this episode with a colleague or a friend. That is the highest reward and sign of support you can give me. So thank you in advance. Please do it, and I'll see you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi Olivier, welcome to the show.
Hi Antoine, thanks for inviting me.
Well, I'm very happy because it's not every day that I have another French guy on the microphone. So I'm not going to make my special postcard of where we are because again, we're in the same room, so I know where you are. But you come from a very specific place of France, specific to me because it's the other end of France compared to where I live. So can you send me an interesting postcard from Nantes?
Oh, okay. Well, that's where I live with my family. Nantes is a very interesting city, very lively, full of culture, full of young people, students. But it's also a city with a history. It was once the capital of Brittany. So, please consider Nantes part of Brittany in France. It's not administratively the case, but it is part of Brittany. So it's a city that is going through a lot of, changes, reconstruction. It was greatly destroyed during World War II, bombed. And now it's trying to find a new pace, transforming industrial areas which are very close or into the city center, into new urban areas, new type of infrastructure. So that's quite interesting to see evolving, I would say. Has the proximity to the sea as well, to the ocean, the Atlantic Ocean. So it gets very popular in the summer.
But you don't have the Rhine River, so still I win.
Yeah, the Rhine River doesn't flow that. We have the Loire River, but it's nowhere as nice as the Rhine, I have to say. Yes.
Well, talking of French references, you've been working for the 3 French majors when it comes to water treatment. Does that make you a pure product of the French water school? I saw you reacting to treatment because water in general, not treatment.
I graduated as an hydraulic engineer, hydraulic and environment engineer from Strasbourg quite some time ago, more than 20 years ago. And I worked for the 3 major companies, so Veolia and Suez. It's there, all different companies. I'm not so sure I'm a pure product of that industry, French industry, because I spent most of my career abroad. So I think I certainly learned a lot in each of those companies, but I also was exposed to very different things and different setup in different countries.
That is actually very interesting because usually you're French, you graduate from a French school in the country where you have all the water majors. It's not every day that you see people that have such an international exposure that like you had, and in places which are, I don't want to sound strange with that word, but which are not the conventional places. So how did you end up, in which country did you work and how did you end up in those countries?
Yeah. The reason I work in the water industry, being very transparent and, almost naive, is I wanted a job that gave me opportunity to travel and opportunity to discover different things. So, when it was time to pick a career, I just looked at, what are the French major company doing? I saw a big strength in the water industry with those companies. And I said, okay, let's try to work in that industry and be exposed to this international activities. And, so that was kind of a key criteria. And I would think a lot of people who have worked in the French water industry are now working on international level or have been exposed to international jobs.
International, yes, but Australia, the US, the UK, maybe more naturally than the places where you were.
Yeah, well, I spent quite a big part of my time, of international time, in Africa. I worked almost 10 years in Algeria, several years in Mozambique, in Gabon, and those were kind of the long assignments that I had. And I wasn't, really, when I, mentioned my early career plan, I wasn't really thinking of Africa, to be honest. I was more looking towards Brazil, exotic places in a different way, probably. But I think I ended up finding in those countries some, very nice ingredients of work-life balance, interesting jobs, great people, motivating people, commitment to what you're doing. And I wouldn't be too emphatic, but some sort of meaning in what you do. So you make career choices kind of by default at the beginning, and then you open up your perspective and you pick things in a different way. But your first attempts at a career, they're really, okay, let's try this. Let's try Mozambique, for instance. Yeah.
Would you say that the time you've spent in Africa dealing with water topics was by any means from another planet, another world, compared at what you saw and lived in Europe? Or is it not as exotic as it sounds?
I think it's one thing about Africa, it's at the same time very different and it has this level of complexity, but at this, on the other end, very transparent. And, when you're faced with, let's talk about, jobs and issues in the workplace, when you see things happening in the workplace or on projects, it's like looking at the same problems from a European perspective, but with a looking glass, So you can actually see much clearer issues, situation, because people are more genuine, I think, more transparent, and what is at stake is more obvious to you. So it's much less complex to understand what is happening, and you do get a lot of key learnings out of that. And you have also more impact because you can act directly on those simple things.
It's interesting because usually, and me the first, I said you were working in Africa. We speak about Africa like it's one thing. And that's something I've been discussing on that microphone with Walid Khoury, how even the countries still don't reflect exactly what is happening in Africa. So you have a lot more to look at. And when you look at the water related topic, if you look at water basins or things like that, it's again another level of complexity. And somewhat it's the unscratched part of the word, at least from a Western country perspective. Did you share that?
It's difficult to compare one country to another. Even looking at North Africa, comparing Algeria and Morocco, they're very different countries, very different culture. Yes, they do share part of the language or some dialects at least, but the culture is different. People are different, and it goes back, I don't know how long, and it's also part of the recent history. There are very different cultures and countries. So, I've spent, talking about Algeria, spent 9-10 years there. I learned a few things. Some things were very obvious in the beginning, how to behave with people and, how you can work together in such I would say, a different environment. But it was also a very transparent and very friendly environment. I had a couple of short assignments in Morocco, and things were simpler, but only on the surface. Things are actually much more complex for me in Morocco to understand. I'm not saying one is better than the other. I just think, each country has its own ways, and you need to understand, depending what you're here for, if you're short-term, long-term, what type of projects you're working on.
We've mentioned that you worked in Africa and in various countries in Africa, but we didn't say what you did there. So what was your duty?
So yeah, as I said, I'm originally a water engineer. I mean, my first job over there were kind of working on, let's say, water supply projects most of the time, and of different configurations, are very often funded by international donors or funding, like World Bank, or I think now they call the International Development Bank. So it was about really managing a water utility, a water company, to upgrade, increase the level of service. And, in some countries, you start with a level of service that is 2, 3, 4 hours of water supply every other day. And you need to bring that up to a constant water supply, or at least a daily water supply during the day. So, I mean, the key challenge that has been asked from international players coming into countries like that is, okay, you need to deliver a better service. You need to make that service sustainable from an economic perspective. And, part of that, you have to create new infrastructure. You have to train the people. You have to involve them to make them autonomous from any international support. So it becomes quite a complex equation to solve. And generally, those are very long-term projects, highly rewarding, but highly challenging as well.
And after that decade in Algeria, you went back to Europe and you did that turn to move to the industry. What brought you to the manufacturing industry?
Just going back one sec around Algeria, that was highly rewarding, highly satisfying project, very interesting. A lot of things were done and achieved with the team, with the people. I mean, from many aspects, from the infrastructure perspective, from the training of the people, how we could really collaborate with the Algerian team and support them in developing skills and organization. So that was, great and quite unique from that perspective. When I came back to Europe and to France, I was in the more, I would say, operational job and very calibrated job into customer services within Suez. And that didn't quite have the same taste as, working on such big projects like the water supply of Algiers. And that, didn't feel the same. I didn't have the same alignment of motivations. And I was kind of starting to think of a new challenge, of different things. And then I got approached by GF completely out of nowhere, I have to say, to work for a manufacturer of piping systems, so GF Piping Systems. At the time it was called a market segment manager, which is a really strategic role to develop the business of GF Piping Systems into water distribution systems.
And that led to your position today, which is?
Yes, today I am a business developer within Georg Fischer Piping System, focusing on water network performance. So basically, how do we work with our clients to have better tools and more efficiency? One of the key criteria being the non-revenue water or the water losses on the system. But this is also linked to water quality. This is also linked to constancy of supply. A lot of the countries where we are operating, people don't have constant water supply. They have to do with 10 hours of water supply per day, 12 hours, sometimes less than that. And we have ways to optimize this. We have ways to improve that, still linked to non-revenue water. But that's, I think, a first nut to crack, the constancy of supply.
Well, we'll come back to that, I guess, in the discussion. But generally speaking, on non-revenue water, which is going to be our deep dive for today, I was discussing on that microphone with David Lloyd-Owen, and he wrote in his Global Water Funding book, he was looking at various studies which are evaluating worldwide this weight of non-revenue water, and he was aggregating the data, and I think he put together that number of the 125 billion cubic meters per year, which are just leaked in various systems that we have in the world. But he is making a distinction there between the leaks which are endemic, because you're never going to have 100% efficiency, and the low-hanging fruits, which you can quite simply, and I'm using brackets here, I mean quite simply solve. And he was saying if you just address the part which we can solve by various means, that's about $37 billion per year in savings. And all these theses in the book is that global water funding, there's 3 ways to close the gap. The first is to get more money, which is not happening. The second is to increase the water tariff, which is not happening. And the third is to reduce how much it costs to operate a water system. And he's saying those 37 billions you could save with cutting the non-revenue water are the low-hanging fruit.
This sounds like a very nice explanation. I really don't know where to start because you just gave a bunch of interesting things and some are very debatable.
Which ones?
Okay, let's start with what we can agree on with those statements. First, there are a huge amount of water that are lost every year. And those numbers, they're quite accurate, I think. I think the latest I had in mind was 126 trillion cubic meter of water lost per year. So I think that's quite close to what you were saying. And yes, that is worth a lot of money. And how you characterize that amount, it really depends. Some countries, when they have water scarcity, they're not trying to fix leaks. They don't have time to fix leak for some reason. They just go for new infrastructure. And I think over the past 30, 40 years, this is what you see most of the time, that especially large municipalities, they go for more water resources. And as long as they have the cash to pay for those extra infrastructure, so a desalination plant, a new dam, reservoirs, and then you increase that. So, what is at stake in terms of money is financing is actually, I think, much more than 40 billion. It's absolutely huge because you can actually waste. It's not exactly waste, but you have to commit to huge investment to satisfy the constancy of supply. Plus, add the urbanization wave that is going on in the large municipalities, add climate change on top of that, the water resources that you're having today, like coastal aquifers, they get damaged by the rise of salinity and you can't use them anymore. So, all of a sudden from, over the course of 10 years, you just lose 30% of your water resources. Take the city of Algiers, for instance. There's a saline intrusion, partly due to overuse of the aquifer, but also linked to climate change. And, basically you're just going to destroy potable water resource out of that. So the economic impact is absolutely huge.
There's much more than just the water. There's all the surroundings which you have to factor in.
Yeah, and you think that for water, you're in competition with agriculture. And, if you have a growth of population, yes, they need water, but they also need activities, food, industry. So this all goes together. So, I would first position, water infrastructure. We could have the same discussion around sewage and sewage treatment, obviously, but it's not a choice of should we finance it? Should we not finance it? I mean, we should all everywhere have a big in-depth look at, what's going to happen with water resources and, what should be the plan for the next 30 years. Because of all the changes we've had because of migration, because of climate change, and, just pretending out of the blue that we can have a low-hanging fruit with leakage, I think it's a bit outdated.
Well, I'm not making a service to David Lloyd Owen by citing him that way, probably, because he's also saying a bit what you're saying here, which is that there's this SDG6, which was supposed to happen towards 2030. And what he's saying is that at best by 2030, what we will have is maybe a plan, meaning that we still don't do it, but at least we have a plan. So he's also saying what you say, which is let's first start by having a plan. But when you say should, what I hear in between the lines is that it's still not happening.
Well, no. I mean, of course, there's a financial equation to this. It's not easy. And okay, yes, you can always, on coastal region, you can always go for a desalination plant, but we all know they're quite expensive to build and to run. And yes, there have been some dramatic improvements in efficiency and cost, but those are still very costly infrastructure to run. And I would say they're also short-lived compared to other type of infrastructure. If you can operate an aquifer, sorry, it sounds a bit weird, but in a sustainable way, this is something you will have for decades, generations to go. So
So what you're saying is that it's not only non-revenue water, the name is a bit misleading. It's also water you wouldn't have to produce if you had higher efficiency.
Exactly. I mean, okay, I think Algeria is a good example of the stress the big cities are under. 10 years ago, or a bit more, 12 years ago, they decided to go for additional desalination capacity, which they did, which greatly helped them to improve the quality of the service. And I think desalination plant in Algeria, they're, I think, one of the top ecosystem of desalination in the world, after Saudi maybe. They are operating this quite successfully, but at the same time, they feel the climate change impact quite harshly on the reservoir, on the water reservoirs. I mean, this year is absolutely catastrophic for them. They didn't have the rainy season during the spring, and they are now working with reservoir and dams that are, lower than 20% of their capacity, and they have to restrict water supply to most part of the country almost. So it's very, very challenging time. But I would say in a normal year, the desalination capacity should be that, extra bit that you need from time to time to run the water supply system. But, at the moment, they are the main source of supply for some of the cities in Algeria. They have to rely almost 60% on desalination plant for the water supply, which is absolutely something. I cannot say it was unpredictable because, there's always someone out there that said, okay, the impact of climate change in North Africa or the Mediterranean region is going to be such and such. But it was hard to believe for people 12 years ago that would be the case. They were only seeing desalination as but a necessary add-on to the complement to the production. No, it's completely changed, and this has quite a big impact. Just to go back on the one thing I disagree. I mean, the most shocking word in what you said, and, having worked with people in water operation and water supply, is this low-hanging fruit concept. I know you did that to provoke me, I'm sure.
It worked.
Yeah, it did. It did badly. I worked on contracts and projects. So let's leave North Africa for a while and go to other projects. I was working in Armenia. Okay, it's middle of it's in between Caucasus and Turkey. It's stuck between Turkey, Iran, Georgia, Azerbaijan, as we've heard over the past year. The network, the water losses in their system for the city of Yerevan was at the time around 85% water losses. Did people complain about water supply? Not really, because they have plenty of water over there. It's next to the Caucasus, so they have fantastic water, potable water resources. Without any drink treatment, no chemicals, nothing. But still, their efficiency was just network efficiency was just terrible. So, we arrived there. So, super easy to improve a ratio of 15%, efficiency of 15%, sorry. So we're going to be, in 6 months, we're just going to crush everything and improve this situation by, we climb up to 40%, 50% easily in 6 months. The reality is that the people who were operating the system, they were not total idiots. They were doing their best and trying their best and achieved quite a few things already. So, their starting point was not 15%. It was even lower than that. And it's not easy to improve a water system. There are, many things you need to understand and consider. And I think the key thing you see in systems that have poor performance is the limited knowledge people have of that system. And there can be many reasons to that. I would say wars have a terrible impact. When an infrastructure was built and, a war happened, I don't care who won, who lost. But, when the engineers leave the country or the city with the drawings of the water system, it doesn't make life easy for the people working after that. So they have to be some kind of pipe archaeologist to dig that out and to improve things. The condition of the system itself, when the system was just designed in a way that it would basically corrode in 15 or 20 years, like it was the case in Armenia, it was all a system full of steel pipe and protected steel pipe. So, system was leaking at I would think almost at every weld or joint. And, no pipe was really watertight, nothing was watertight. So, yeah, you have thousands and thousands of kilometers of pipe that are leaking. So, okay, the only solution is to replace the pipe. You can also play with different things, but it's quite challenging. It's a huge amount of money that you need, and you need to dig out the pipes. And when you start playing with excavators all around a city of 1 million inhabitants, in the case of Yerevan, you do get a few issues with the municipality, with the police, with traffic control and things. So, it's low-hanging fruit that really doesn't resonate with my experience. And I think it doesn't give an accurate picture of the people working in water supply in general, whether there are international firms, local or anything. Nevertheless, there are things that can be done. I mean, with experience and background, and there are a few mistakes that can be avoided. And there are things that bring faster results than others. But just to make things clear, it comes with a very high level of commitment and hard work, and there's no such thing as low-hanging fruit. Some things are a bit easier than others and more obvious with experience, I would say, but no low-hanging fruit.
Okay, so let me withdraw the low-hanging fruit. Sorry for that one. But just, when you tell me the network had an efficiency of 15%, it sounds like pretty obvious that the solution is not to fix the leaks, but to replace the network. Really, from an outsider perspective, do you see a tipping point in the efficiency of the network starting where it would make sense to repair and improve, and below that tipping point, it would simply be better to build a new infrastructure?
Okay, I will answer your question, but there's something I want to mention first, because that kind of before thinking of renewing a water system, the first thing you should look at is the old pipes that were replaced 10 years ago, 20 years ago. Can we make sure they're out of service? The history of a piping system is such that a lot of the issues come from the pipes that you think you had disconnected. So everybody believes they are disconnected and not operating anymore. But somehow, somewhere, someone left a valve. Okay, it was closed on the day of the decommissioning, but he thought it was a good idea to keep that valve just in case, you never know, it gives you safety. And then, for some reason, one day that valve was open and remained open. So you thought you had decommissioned 30 kilometers of leaking pipeline, but they're actually still in operation.
Do you speak by experience here?
Yes, I do. No, and that's the first thing you look at, to decommission old pipe. And it's quite a good strategy because, as long as you have drinking water available or potable water available, and if you have a lack of water supply somewhere, okay, when, you had the pipes, you would just build a new pipe to that area. And so you had 5 pipes supplying the same area. And at some point in time, you think, okay, I don't really need that hydraulic capacity. Maybe I should decommission one of those pipes to just to see what happens. And most of the time it comes into an improvement. The other thing, just to give you some funny things and funny ideas is, you worked in Nordic countries and okay, frost is a problem and freezing is an issue. So you have to bury the pipe quite deep and protect them or both, just to avoid the pipe freezing. Especially when it goes into low flow condition, no dynamic movement. So okay. When you have a very rocky soil, like the Caucasus, for instance, it's a lot of hard work to bury the pipe very deep, because you have to excavate rocks, basalt, very hard rocks. So it's too much effort to bury the pipe deep. So, okay, you bury them at the depth you can, somewhere between 50 centimeter, 1 meter. But, in this part of the world, freezing conditions are very, very harsh between November and April. So, you get frozen pipe very often. No, I never had a frozen pipe in the water supply system of Yerevan. I can't remember of any. You know why? Because we always left the washouts open, so water was always flowing. So the key thing was,
There are welcome side effects to the non-revenue water.
In this case, yes, but how you handle the washout, how you handle your system, you need to understand how things are run. What is worst? to have a completely frozen piping system where you're going to destroy the supply and won't be able to get back to it in 6 months? Or do you open the washouts and lose water? It's a strategy.
If I get you right, the very first foundation block is to have a better understanding and a better knowledge about your network. That is really the thing that you need.
Yes, and every serious water engineer would go in that direction. You have a limited budget for anything you do. You have a very limited budget compared to what is at stake. We're talking about all this infrastructure, and you're only playing with, little millions here and there, and you need to know where to focus your effort. So, the first thing you should invest into, is a proper mapping of your network, better knowledge, as much as information as you can gather, just to see a clear and full picture. When I was working in projects where I didn't have that, it took me, 2 years, 3 years to get there. And that was quite painful. And, when you're done with that, you're kind of completely exhausted, but you think you've achieved nothing. But believe me, I've been in this other situation where I arrived on a job where this had been done, and it was fantastic. When this is done properly, you can achieve so much more. But you should never forget about that phase. So, but for 2 or 3 years, no low-hanging fruit, no real quick wins or things. No, you're not talking about that. You're talking about establishing the base of a proper restructuring and operation of your water system. And, consulting engineers are very important in that respect. And I wouldn't say they're neglected. They're very often part of, international donor strategy. But, I think we still underestimate the value of such jobs.
It's a topic we somehow covered with Hélène Gauthier from NIR. That was by season 2, episode 1, I think, where we were discussing how do you have a better patrimonial understanding of what's buried out there, and to go from this situation where you have things buried to a situation where you have a very, in that case, digital vision of what is laid at which place. So if you want to have a deeper dive to that matter, I recommend you that discussion I had. But let's assume for today that we have done that mapping. So we have that understanding. We've made that 2 years investment into better understanding the network. And then coming back to my question, now we have kind of a precise idea of the current efficiency of the network. When would you decide to do something, and what would you decide depending on those results?
What you learn from that first phase is, okay, there are different models that you can use. And I think the first thing is to look at asset management models where, okay, with different tools, depending on the pipe material, depending on you estimate the remaining lifetime of a piping system. And, you theoretically program your pipe renewal. It's a very theoretical exercise because you never get the necessary budget to do it, but still you're going to prioritize and organize things. And I think it's the first good use you can make of your initial consulting job on the thing. And then it gives you a prioritization with different criteria of, what you should be doing. But, think this is only a limited budget that you have, I think you've been confronted with that as well, that you have budget to renew 0.2 to 0.5% of your network every year. Yeah, some countries do better than that because they get extra funding at some point, but this is more or less what water services can afford in most part of the world. So, it means a theoretical lifetime of 200 years average for your system. So way too long for any pipe material, any piping system. So you have to be smart, okay, on your asset management renewal, and, just pick the right places and just spend the money where you need to spend the money. So once you've done that, you haven't fixed all of the issues. You've fixed, let's say, 25% of your problems and issues. And then you are faced, from whatever a result of past installation, could be a bad soil condition, could be bad installation, could be too much pressure because the system was initially designed for a different pressure from a different water source and you didn't manage that. So, you need to understand, okay, what is the constraint and the pressure on my system, and can I manage it a little bit better? And that is when you start to think of tools like pressure management, for instance, and you're going to say organize your system in such a way that you're going to pressurize your system just enough, not too low, not too high, but just enough to be able to supply everyone in decent conditions throughout the day. So especially you try to minimize pressure at night and increase pressure during the day, but just at the right level. And this is quite challenging because it requires your system to be built in what we call in a district metered area. You don't necessarily have to build a meter, but if you place a pressure regulation equipment, you generally put a meter next to it. And you need to sometimes redesign your system depending on elevation, depending on the mapping that you have to make that, let's say, more logical operation of the system from a pressure point of view. And that is, let's say, more designing job, design engineering. And let's say that's another 25% of your strategy and things you can do. The other part, I would say, is really linked to some issues that happen. And, you can talk about pipe burst and leaks, and you need to manage that because sometimes, a pipe burst is not really the result of an aging pipeline. It's just, one localized situation where for some reason the joint was damaged, and if you fix that, your line is good. If you fix that one, or it was damaged by external, and this you need to keep an eye on all those things, and you need to monitor your situation, and that's really an operational job. And to have DMAs in place and monitoring of flows and pressure in the system really
DMAs?
Or district metered areas. Yeah, sorry, we mentioned district meters, so DMA, district meter area, or DMZ, district meter zone. DMA became more common, I think. Yeah, and you use this, let's say, theoretical model of your system where, okay, DMA1 should have so many cubic meter of water with a night flow of 10 or 5. And when you start to see a discrepancy in those values, you say, oh, night flow became 20. I must have an issue there. So I have a response team, doing my leakage detection, and another response team going for the leak repair. And this part of operation is important. The common mistake, but it's becoming less true, is to think this is the only thing you have to do. This is the main thing you have to do. Do a bit of pipe renewal, but then focus on leak detection and repair. I think that's a very incomplete strategy.
Why so?
Well, because you never know when a leak appears, if it's the result of a punctual problem, or the result of an aging piping system, or extra excessive pressure on that system. So if you focus solely on corrective maintenance, and you sometimes never eliminate the cause of the problem, that could be simply, I'd say with brackets, excessive pressure on your system. So you always need to kind of manage a good asset management plan, pressure management, and I would say even design of the DMAs and design of the different pressure zone in your system with a good maintenance strategy. The weight of the actions and the importance varies, depends. A water system is generally a sum of hundreds of water systems. So some part of the same city are going to be very advanced when it comes to pressure management, or with a very, let's say, fresh piping system, very new, so they don't have the same priorities and the same issues. So, on any scale, you need to manage those skills of operations, asset management, and let's say, network design and pressure management.
So what you're saying is that all of these steps really don't work in isolation. You need to do your homework and to map everything, because that is going to feed into your DMA, that you have a good understanding of what does what. Then you have to regulate your pressure. You have to go to look for the leaks. And on the same hand, you have also to have still your brain on to say, hey, I see regularly something happening in that district, then very probably I have a bigger issue and I need to sort that out. But if you have only one piece, you're a bit left out of information. You cannot just have a holistic approach.
Yeah, I think you need to experiment all approaches and test them on your system, because you despite this initial consulting job that you mentioned, you're trying to understand and map out their system. You never know 100% of the information. So to continue this kind of project, whether they are leak detection or pressure management, helps you fine tune your knowledge of your system. Whether you know more about the condition of the pipe, like, I repaired that 60-year-old ductile iron pipe. you should have a look at it. It's completely corroded. Oh, that's an indication of what we don't know yet, but it's an indication. Could be normal aging of the pipe in a corrosive soil, could be some localized electrical influence from whatever tramway line or anything. So, could be many things, but you need to look at whenever you have the chance to physically touch and see your piping system, you need to capitalize that information into your mapping system, GIS, Geographical Information System. GIS is much broader, and continue to learn on your system and, fine tune your skills when it comes to water loss management and asset management.
So water network management is a bit of forensics. You get the body regularly and you have to inspect that body to understand what probably happens around that piece of...
Yeah, that's a good metaphor. And to be fair with you, at some point in some jobs, I was seeing... You remember that TV show House MD?
Yeah.
Yeah, I was very, pretentious, but I thought sometimes I saw myself as this guy, looking at a piping system and, sniffing what was happening, and just throwing it away, some diagnostics and people listening to me and just going out for...
And eating some pills as well.
No, I mean, just going a bit being a bit more down to earth. Yes, it does involve probing and testing and trying to see what happens. I mean, there are some general solutions like, okay, let's renew that part of the system. Let's not waste our time into leak detection. I think this is all whatever asbestos cement system from the 60s, 70s, and we have other reason to renew that. So let's do this. But even doing that requires knowledge. Okay, where are the pipes? Where am I going to disconnect them? How many water connection do I need to renew? What do I need to do? And it requires a lot of investigation and fine knowledge of your system. Again, if you're not 100% sharp on what you're going to do in the construction work and your renewal work, you may leave out a connection somewhere, a piece of pipe crossing between two networks, and then you're completely wasted all of your effort. So it's a very difficult job to be done properly. What was that? What you said? Low-hanging fruit. Yeah.
So I get that it's only one brick in the wall, but can we uncover that brick of pressure regulation? How do you regulate the pressure on the network? You explain the rationale of why we shall do that, but how do you actually do it?
There are two ways, or let's say three ways. Going back to the mapping and elevation, you can just position your storage system, your storage tank, at the right elevation and design your piping system and, freeze time. Nothing is going to happen for the next 50 years. No extra construction, no extra water usage. And you design your piping system. Everything is frozen and pressure is perfect because you perfectly design your pipeline with the head loss in your piping system. So that's the first way.
So that's the case of Vatican, maybe?
Well, that's an interesting one as well. I never worked there, but I heard of people who work there. But they do have a lot of issues with, typically, piping system in Vatican is an absolute nightmare because they don't know where the piping systems are. They have absolutely no clue. And can you picture an excavator in the middle of Vatican City? I mean, maybe they had a bit of time, unfortunately, over the COVID crisis, but it's just absolutely not possible to do anything. So,
okay, I sidetrack you. Sorry.
Yeah, no, but that's a very interesting one. The very big challenge, I would say. I would be really interested in knowing how they're going to tackle this one. So let's say this very first method, which is time frozen, perfect conditions. But guess what's not really what's happening in real life. Okay, I guess that's not a surprise. So, okay, now we have to deal with all sorts of events. So you've positioned a design a network and you have to deal with extra consumption, population changes, extra usage, many different things, or, change of resources, things happen over the lifetime of a water system. So then you start, okay, I want to manage pressure on that system. So, I cannot just use the storage tank elevation. I need to use devices to do that. So the one that I will first mention that I'm not going to cover in detail is using pumping stations. A pump just creates artificial elevation and you can regulate that elevation with different devices. So variable speed drive pump or, simple pump or increased number of pumps can adapt the pressure on your piping system, and that's something that is commonly used to manage pressure on a distribution system. Still, it's electricity driven, it's a mechanical equipment, requires maintenance, variable speed drive. I mean, it's a very well-known technique. I mean, it's and it works. You can see some operators, they don't really like it because they don't like the maintenance and cost and risk associated to it, even though it's perfectly controlled by the manufacturers. So, what we see that is more common in Europe, in the US, in many countries is pressure regulating valve. And basically it's a mechanical device, that creates a flow constriction, which target is to reduce pressure or adjust pressure. So there are different functions, but let's focus on pressure reducing, so downstream pressure regulation of the valve. And that device just makes you have a steady pressure, whatever the flow condition into your system. So you create kind of a fixed point of pressure in your system that you can control and adjust. And with that pressure, you can, decide, okay, I will cover a DMA, a district meter area, a part of my system. And by operating that device, you decide the scope and the limit of your DMA. So there's a bit of hydraulic calculation, trial and error attached to it, but you just break down the pressure in your system. Then, that's just a simple single set point thing. You can adjust that pressure and pressure management, as it's normally called. You can actually program that set point of pressure, and program it according to the demand, let's say. You can program it according to time, but in the end, what matters is the demand of water. And generally, you try to adjust the pressure higher during the day at peak hour, because that's where there's more water demand and you have more head loss on your system or pressure loss on your system. And you try to minimize it at night, because that's where you have less pressure loss and the risk of having excessive pressure on your system. So you try to adjust that pressure set point. This is also true for pumping station, but this is we're talking about valve now. To just give what you need in terms of pressure on your water system to satisfy everyone and every usage of water. So simple in principle, but as it's a mechanical device and with a bit of electronics, if you try to program that set point, it's subject to failure, maintenance, and it has some limitations in flow depending on the usage, depending on the flow condition on the system. Systems are all different, so how can a single design of mechanical device can cope with all those different situations? I would say that's the trick. That is to master.
And what is the state of the art today? Because that sounds, if you take a piping system, regardless of the material, everything, if you consider it's laid down properly and you can decide that it's going to run at that pressure, then you take your curves, and probably that one is going to last the 200 years that it's supposed to last, as it has any ways to cover that if you're replacing 0.5% of your network. So that sounds to me like, I'm not saying low-hanging fruit, I'm going to say the perfect solution to a complex problem, but with a caveat, which is what you just explained, that it may be failing, it may be a bit more complex than on the paper. So what is it like commonplace today? Do you go to your next plumbing shop and you buy a pressure regulating valve? Is it really something obvious?
Pressure regulating valve is what many people have at home before or after their water meter. So a lot of pressure regulating valves are installed in individual houses or flats. So that's something that is quite common. So this is something that is being done, and it's always part of a design. When we talk about pressure regulating valve into distribution system, we're talking much slightly bigger valves, sometimes very big valves, and you don't find that to the next plumber. And when you have to, you think of installing such a device, you always evaluate costs or constraints and benefits. And that's probably, say you have a system, you have a little bit of leakage here and there. Is it really important to work on pressure management today? Yes, because I reduce my pressure, I will save a little bit on leakage. If you have less pressure an existing leakage. By reducing pressure, you will reduce your flow of leakage. That's obvious for hydraulic guys like us. But it's kind of for some people, some organization, is kind of a nice to have benefit to say, okay, I had leakage of 10 before. No, I have a leakage of 8. Yes, it's an improvement, but do I really need to go through the discovery of a new type of device and having something mechanical on my system that I have to maintain, that I have to deal with? Is it really worth it? Yes, a decent result, but something that is more of a nice to have than anything. So we maybe get back to the nice to have in this current climate change and water scarcity topic. But yes, talking about the design life of a piping system, yes, it's been designed for 100 years. If you do a proper polyethylene piping system with proper welding, with trained people, you can expect a lifetime of 100 years, and you don't expose it to very excessive pressure, for sure. But who on earth can guarantee that system was installed 100%? I'm saying 100%, not 99.9, but 100% by the book, within a soil that is 100% the right granulometry of sand and tiny rocks, and 100% there won't be any earthquake happening, soil movement, ground movement, freezing conditions, whatever can happen over the lifetime of a piping system. Who can guarantee that for the next 100 years the condition will be such? No one. Okay, so when you have a way to reduce one of the key parameters of stress on a piping system, which is pressure, and optimize that and say, okay, by adjusting my pressure and managing my pressure, yes, it's a new system. Yes, it has absolutely no problem today. You are giving yourself a chance of increasing that theoretical lifetime from 100 to, let's say 200. I mean, who cares today? You know what I mean? But, the reality is that 100-year lifetime system, you might start to experience issues in 20 years, in 30 years. And if you can push that back in time, this is a very nice gift you give to the next generation. Not going to be your generation of people operating the system, might not be even your sons, your children, it might be the next generation. But if you actually manage properly pressure, you just control one of the key constraints. What can you do about earthquake? I don't think much. What can you do about climate change? We hope we can do something. But, pressure is something you can do something about in design and at a very, interesting cost today.
To round off our deep dive on the topic today, can you tell me what's the partnership you currently develop with Oxford Flow in that area of pressure reducing valve?
Yeah, to the point we were discussing earlier, we're not changing the technology with what we're doing today in GF piping systems with pressure management. We have just come up with a design and an operation of pressure management that is much easier to grasp for water operators, and that gives them much less headache, gives them much more trust into their operation and system. So we, as GF Piping Systems, we've been designing and making valve in a polymer material for decades. I've only been working with this company 3 years, but if you look at the history and the experience of the company in designing valves, it's huge. And we very opportunistically, we came across a UK-based startup called Oxford Flow. And they had, they're a spin-off of Oxford University. They were working on a jet engine, a famous jet engine company in the UK, operating for Airbus and Boeing. And, part of that development, they developed regulating equipment, regulating valve. And one kind of sub-application of that was regulating valve for the water industry. And they had just managed to design a valve that is very simple mechanically, I was very astonished when I came across that one, and this has the same effect on most of the water professional I share it with. It's just beautifully simple. It's just a few components, an axial flow, and with a very low maintenance requirements, made of polymer material, very light. So they had come up with this design, and we just realized the big potential this could have and the big problem solver. I mean, let's say it was taking out some of the headache operators had, which was a big hurdle for adoption of that technology. And this is what we see today, that people like how simple it is to use. They have added benefit coming in terms of pressure stability and regularity of the pressure management and the full spectrum of pressure management and flow and pressure. But what they're really sold on today is how simple it is to manipulate, install, commission. It's just like very intuitive mechanically, and that's very interesting. So we invested in this startup, Oxford Flow. It's not a startup anymore. No, I mean they're also developing products in other industries like oil and gas. So they're very creative, very innovative. And we have a global partnership with them to supply the water distribution market, the municipal water market, with these products.
So it sounds to me like you a bit closed the loop here, because you didn't like my low-hanging fruit, but you're saying that you're now proposing a solution which is working on the acceptation, because it's a bit easier to work with. So maybe you're making all of that a low-hanging fruit.
I think the first thing for technology providers like us is to understand that low-hanging fruit is, not as obvious as it sounds, but our responsibility, our role as a manufacturer is to make technology more affordable. I mean, I'm not only talking cost-wise, I'm also talking in terms of efficiency and requirements for maintenance and ease of use. And, that's what we do becomes a no-brainer and part of the habit. So, of course, it's a big commercial win for us because, we have a great product and we generate great business. But for the water utilities, it's also, one less thing they have to take care about. Remember, they have to know about their system. They have to keep track of what is happening. They have to repair leaks. They have to detect leak. They have to check, why is this pipe corroded? So if you can take one headache from them, it's fantastic. And then they can focus their limited time and budget on other things. And I think when you introduce a new technology, if you bring that no-brainer situation, no headache situation, you have a big advantage because you're actually giving them time to work on other very important aspects of their operation and business. And time is always limited within water utilities.
Well, I could follow on all of those topics, but I have to be cautious of your time as well. So I propose you to close our deep dive and to switch to the rapid fire questions.
It's time for the rapid fire questions.
So in that last section, I try to keep the question short and you have to try to keep the answers short. Don't worry, I'm the one to sidetrack all the time. My first question is, what is the most exciting project you've been working on and why?
Yeah, I would like to say it's the project I'm working on right now with GF Piping System, but it's a bit too early for that. Yeah, the most impactful project I worked on myself, was the constancy of supply for the city of Algiers in Algeria, just because it was this combination of huge engineering work, construction works, teamwork, learning experience. When you can contribute as much as you learn, it's just a fantastic and exciting experiment.
What is your favorite part of your current job?
I think the customer interactions is the best. I mean, that's the fun part. A lot of problems coming up, but it's really the fun part, exchange of experience. And I know where most of them are coming from, but this exchange is always fun and rewarding, challenging, difficult, but yeah, rewarding.
What is the trend to watch out for in the water industry?
Well, I still think, I've been thinking that for the past 15 years, maybe, but digital twins, we can talk about water networks, but, real intelligence of digital twin and proper modeling of water systems, whether they're treatment, supply, sewage, it's hugely powerful and completely unused most of the time.
It's very interesting because I was reading a GWI paper this morning, which was listing the top 10 water applications or water technologies of the decade and the flop 10 water technologies of the decade. And they had this digital twin floating in between because it's not yet adopted to the level you could say it's really one of the top 10 applications. So it's somehow characterized as a flop, as it's not yet adopted. And on the other hand, it could be so disruptive. I mean, apply a digital twin to your network, which is now perfectly balanced with pressure regulation. And now you can play a lot with the pressure and find out much more new things. I'm not trying to reopen the deep dive, but it sounds to me like something which is, I mean, we'll see in the next decade how big it becomes.
I was in a couple of conferences this year, and I've seen, research institutes in Northern Europe doing some great stuff around, what they can do with digital twins and modeling a water system. I was quite impressed, and I thought I had a good knowledge over those things, and I was really I could see something is happening.
What is the thing you care about the most when you're working on a new project, and what is the one you care the least?
Maybe because I'm getting older. I think to be surrounded and be by motivated people, driven people, is really a key parameter. And if being at least a positive influence on this, I wouldn't say the key driver, because we always end up in different situations and positions. And my goal is not to be the big influence. My goal is to be surrounded and contribute to be a positive influence on a project. So the people you work with, you become picky, and if you can have your word on this and influence that's very important for the fun part of things, I would say. And the least important, maybe the management position is probably the less important things for me today. Recognition of a management level, of a seniority level, is absolutely irrelevant for me today.
Do you have sources to recommend to keep up with the water and wastewater market trends?
Yeah, I know about this guy. He's doing this excellent podcast.
You said you didn't care about money, but you're still going to get my check for that. So.
Yeah, for sure. No, but I mean, this is an excellent source of information because it's direct source of interaction with professionals, and I think it's quite good. And you give people the opportunity to deep dive on topics, so I think it's all right. Apart from that, I would strongly recommend to avoid LinkedIn, because
it's interesting. Everybody tells me LinkedIn as a recommendation, and you recommend to avoid it.
Yeah, I mean, you don't get the full pictures. I mean, I try to interact sometimes on LinkedIn and trying to give a chance to people who publish something to, okay, you mentioned this and that in 5 lines in LinkedIn, but I mean, yes, you use the buzzword hydrogen. Yes, you use the buzzword, but there's probably something very interesting behind that, but, we didn't quite get it. So I'm always trying to give a chance, to good people and most of them do, but, by the time you achieve the answer to your question, that post is long gone, and nobody's going to look at it. So it's really fast, and really all you pass on is buzzwords and things. So yes, it's good for networking and things like that. But to know more about water, interact with people. What you're doing is excellent on a personal level. If you're interested in a technology, if you're interested in a startup, a venture, a topic, LinkedIn is great to contact people and to engage with them. But that's just like a phone book if you want. So
you use it as a source, and then you take the discussion off platform and you discuss actually with people.
Yeah, that's probably the best advice to give.
You would be surprised. I had people on that microphone recommending Twitter, which is even like 1 million times faster than LinkedIn. Okay, it was one guy, Adam Tank, recommended Twitter, but still, I think pace is.
Yeah, probably with time. You will tell me, because you will have that experience. With time, you get sufficient exposure and better response from people if you are a known influencer and things like that.
But I see what you mean in terms of course, you have just so much space and so much time, so it can stay quite superficial, and it's quite hard sometimes to go really in depth of a topic. But yeah.
Yeah, I know I sound like a dinosaur when I say that, but no, you can use digital tools to better interact with people, but it could be anything from WhatsApp. Emails are not really great, but Instagram, WhatsApp, whatever helps you share media content in a fast way, and you whatever, it doesn't matter. It's a smile, you interact with people, you get feedback. And if you connect, especially in COVID times, if you have this ability to connect to people and keep exchange going, you continue to, even if you don't build your professional experience, you build your network, and you create opportunities for tomorrow, and you can connect to people for tomorrow. So I think as long as it's linked to people and interaction with people, any tool is good.
And to close on that, keep exchange going, would you have someone to recommend me to come on that very microphone?
I don't know. I mean, there are great people I've worked with. Most of them are retired now. Really inspiring people. Well, I think if you could have Diane Darras on your microphone, who was a key management person within Suez and also chairman of IWA, that would be great. I mean, she probably has so much to tell about the water industry in general.
She's on my bucket list.
Okay. I mean, she's a very inspiring person.
Well, thanks a lot for the advice. Thanks a lot for that very thoughtful discussion. I really enjoyed that. See you soon, and probably with the new developments. And I promise you, I'm not going to send some buzzwords at you like low-hanging fruit. I started something which was really interesting after that, but I didn't want to insult anyone.
No, you didn't. I don't think you did. Thanks. It was a pleasure, Antoine.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.